So today, what we're going to be reviewing after we do finish this trigonometry, we're going to review chapter 2 and 3, which is about graphing of linear equations, um, how to write the equation of a line, and also how to solve the system of equations. We're going to go over a couple of problems of that nature. Okay, so I'm giving you a couple minutes just to finish this up, then we'll do it together.
Professor, good morning. What day is the midterm? Because this is the last day of classes. 18th is on Monday. I'm guessing is the week before.
Um, as far as I know, our last day of class is actually 2 weeks from today.
Oh,
Okay, well, today is the third, so that would be, I think, the 14th of May. And I see the final is tentatively scheduled for the 18th, which I think is a Tuesday.
okay,
But there's nothing, I haven't announced it yet because until I hear a final, they always make adjustments towards the end of the term. So until I know for sure, I'm not making any decisions or giving you any announcements about it.
okay.
Okay, but
Mm-hmm.
that's basically, as far as I know, the schedule. But I do know that we have class through 2 weeks from today. In other words, after today, we have 6 classes.
Okay, thank you.
And as I said, we'll be finishing this chapter today. This chapter on trigonometry leaves us chapter 8 in the book that we did not cover, and that's what we're going to
Good
be.
morning.
Good morning. Okay, so Jonathan, I hope I
Good
answered
morning.
the question in some fashion that
Oh, you answered it. Thanks.
I just said I don't know. So that was my answer. I'm not
It's fine. Thank you.
sure, but a little bit of an idea. Okay. Usually when I don't announce something, it means because I don't know what to. Okay. Um, Anybody want some more time to do this? Or should we just go to this directly? Okay, this is very typical type of question you might see on the final. They will give you a picture of a triangle. They'll probably give you two of the sides. They don't have to give you all three sides because in a right triangle, there's a way of figuring out the third side called the Pythagorean theorem. And then they'll ask you to find one of the six trigonometric values or ratios, because they're all fractions. Now I ask you to find the cotangent of theta and sin inverse of theta. Let's just put the important information you need to know about this. This we know number one, the Pythagorean theorem, a squared plus b squared equals c squared, tells us that we can find if we have two sides of a right triangle, we can figure out the third side by this formula. Then we know, so that's number one that we know from this chapter. Number two that we know from this chapter is what I'm calling SOHCAHTOA. We have a picture of somebody coming in from the pool and soaking his toes to warm them up. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that tells us about the three principal or primary trigonometric functions: the sine, the cosine, and the tangent. And the third thing we know is that there are three, I'll call them secondary. The reason I call them secondary is because really, when we really want to figure something out, we figure the sine, the cosine, the tangent. That's the one that has values on the calculator. But there are three others. There's the cosecant, which is the reciprocal of a sine. There's the secant, which is the reciprocal of the cosine. And there's the cotangent, which is the reciprocal of the tangent. And basically, those are the three major important pieces of information you need to know for trigonometry for this. This is not all of trigonometry. This is only trigonometry of the right triangle. There's a lot more to trigonometry. I've probably told you this already. Trigonometry is pretty much 3/4 of the course that you take if you take pre-calculus, Math 151. Any of you that are going into anything science-based will be taking Math 151, pre-calculus, and a very significant part of it is the study of trigonometry, which is a lot more intense than what we do here, which we're sort of spending 2.5 days. Obviously, spending half a term and spending 2.5 days obviously means there's a lot more to it than all you have to know is three major facts. And you have to know these by heart. This is not something that's going to be given to you on a chart that you're going to know. You're going to have to somebody.
Professor, I cannot mute that person.
I'm sorry, I muted everybody, so now unmute yourself. I don't know who I was talking to. Who's asking me a question?
Professor, I'm not host.
Yeah.
I couldn't mute the person.
Oh, okay. I forgot to make you host. I'm going to make you host right now.
All right, appreciate it.
I forgot about it. I am not. Oh gosh. Let me find you. Why am I not finding you? Oh, here you are. Okay. Melissa, you're the host now. Okay. So, given those important facts over there, let's see how as I said, that's everything we learned. So somehow the question here is going to be making use of some of those facts. So number one, let's see what they want me to find. They want me to find the cotangent of theta. Notice they put the theta up here. Remember, the theta is another name for the angle. It's like an x, it's a variable. Okay, so we know from what I said over there that the cotangent of theta is the reciprocal of the tangent. So I really want to figure out what the tangent of theta is. Because once I know what the tangent is, to find out the cotangent, all I have to do is take the fraction and flip it over. And I know from SOHCAHTOA that the tangent is the opposite over the adjacent legs in the triangle. So let's now go, now that we have a picture of what we want, let's go to our triangle and see what we have. Now this is where they placed my tangent, my theta. So therefore, I'm going to label the sides based on where the theta is. Now, the hypotenuse we know is always that long slanty side. It's always the longest side. It's the one that's directly across from the right angle. That's the hypotenuse of the right triangle. Then we have the opposite and the adjacent. Now notice the hypotenuse has nothing to do with the angle. the hypotenuse always stays the hypotenuse. It's based on the right angle. But opposite and adjacent are based on their location in reference to the angle we're interested in, which is right here. Now, the one that's directly across from that, that's what's called the opposite. And the adjacent of the one that's connected to it, of course, the hypotenuse is also connected, but we're talking about the one that's connected to the side that's not the hypotenuse. This is my adjacent. And I just said that the tangent has to be the opposite over the adjacent. Now, I already know what the opposite is because I have it right here on the triangle. It says it's 5. But what I don't have is the adjacent. So the first thing I have to do is figure out what is the adjacent side of this triangle. And again, to do that, once we have two sides of a right triangle, we use the Pythagorean theorem to figure out the third side. Now, usually I call this the A, this the B, and this the C. So it's going to be A squared plus 5 squared equals 17 squared. If you would have written this as 5 squared plus b squared, that would be perfectly okay. What you have to be very careful about is what goes on the other side is always the hypotenuse squared. Okay, so now I've got to figure this out. So this is a squared plus 25 equals 17 squared. So
189. 289.
289, thank you. It's 289. And of course, you can just do that on your calculator if you don't want to do it in your head. 17 times 17, you can do that. And of course, you have to then bring this 25 to the other side. So that'll give me that a squared equals, well, 289 minus 25 gives me 264. If you notice, I am using my calculator. You should be using your calculator for this, because the calculator makes things so much quicker and more accurate. Of course, since a squared equals 264, I have to do the square root of 264. Remember, we only use the positive numbers because we're talking about the sides of a triangle. Now, I want to see if I can simplify that. Let's see if I can simplify that side. So I'm going to I think I can divide this by 4. Yes. This is the square root of 4 times the square root of 66. Remember, when I want to simplify a radical, I want to pick a number that goes into the original number that's a perfect square. And I try easy numbers like 4 or 9, numbers like that, because those are likely the ones that might work. And we know the square root of 4 is 2. So this becomes 2 radical 66, which is this side over here in the simplest radical form. Okay, now I have my whole triangle solved. And sometimes all they're asking you to do is they may ask you just to find the side, but in this case, they asked us to find the cotangent. So I'm going to go to the tangent. The tangent is the opposite, which I see I have it marked here as 5. And the adjacent I have here marked, it's 2 radical 66. And since I asked you to find the cotangent, I immediately take this and flip it over. It's the reciprocal. So it's 2 radical 66 over 5. And that would be your answer in simplest, what we call simplest form or simplest radical form. Notice it involved using pretty much almost all of that information. Obviously didn't ask about sine or cosine, but those use all three of the important facts that we learned in trigonometry. Um, Usually they do ask to give you the answer in simplest radical form. Just to remind you, where did the five was over here. I gave it to you. This was 5 and this was 17. That was the facts that I originally gave you. Kashira, are you okay with that? Oh, okay. I know what happens is, and if you notice, and you're going to need, when you're going to sit down to do these, you want to have a lot of paper. You want to have, because all of these do involve having a lot of different steps. They're not difficult steps individually, it's just there's a lot of steps in total. Just wanted to, sometimes they ask you to give this value in decimals. If they'll ask you to give in decimal, they'll usually ask you to round off to the nearest thousands, to 3 decimal places. I'm gonna try it on my calculator. Everybody, if you have a calculator, try converting this to decimal. So I'm gonna put 2. I'm gonna press my square root button. If you don't know where your square root button is, you've got to make sure that you find out, because that's a very important button to be using. So I have 2 square root of 36, square root of 66, and I get out of the square root and I press divide by 5. And what I get in this case in decimal form is 3.249615362. That's everything that I see. If I want to go to the 3 decimal places, if I want to run to the nearest thousandth, I go to that would be after the 9, I would be stopping, but I see that the next number after the 9 is a 6. That means I have to make this really a 10. In other words, I have to make this 49 into a 50. So it's the nearest thousandth, the answer is 3.250. And notice I put in that 0, which really doesn't do anything, but it does show that I rounded, or that this was rounded off to 3 decimal places. It's the same as 3.25, but then it looks like you only rounded to 2 decimal places. So keep that 0 there to show that you've gone to 3 decimal places. Again, more likely the question would ask you to give your answer in radical form. Kashira, okay, let me look at, I see there's some questions. Let's see what the questions are. Okay, so Khadija, as you see, you got the right number on your calculator, but you be careful about when you round it off. When the circle is always on the top of the triangle, it's always going, no, it's not always going to be 10. It just, the reason we pick tangent has nothing to do with where we place this. It's called theta, by the way. This symbol is called theta. Theta. Kachira, you following this? I specifically asked you to figure out what the cotangent of theta was. And when I know that the cotangent is the reciprocal of the tangent. Remember, these all come in pairs. The cotangent is a reciprocal of the tangent. The secant is a reciprocal of the cosine. and the cosecant is a reciprocal of the sine. Since I asked you for cotangent, I went to tangent because I know that if I get the tangent, which I got as 5/2 radical 66, all I have to do is flip it over and then it will give me the cotangent. Is that clearer now?
Yeah.
Okay, now, Cheryl, you want to know how I put it into the calculator. So here's what I did. I'm not sure about your calculator. Which calculator do you have?
Texas 30X.
Okay, do you have, let me, okay, so it's this was our answer, okay? I'm erasing this.
Mhm.
You see this symbol. I think it might be like this. You might have a button that says X squared, probably down the first column. Do you see that button? You see a button that says X squared.
Yes, I see that. Yeah.
Is
Mhm.
there, is there a square root sign above it?
Yes, there is.
Okay, so here's what you do. You
Mhm.
press your second button. You know where the second button is?
Yes, yes,
Right at the top.
yes. I press it
You
already.
see a button that says second?
Yes, I press
Press the
it.
second button. And,
Mhm.
oh, okay. Okay, so here's what you're gonna do. So you know how to do that. Here's what you're gonna do. You're gonna put it in just the way this says. You're gonna put in 2, then
Mhm.
you're gonna press your second button
Okay.
and your X square button. And what's gonna pop up is a square root sign, right?
Okay.
Are you with me?
Yes. Yeah.
And
Yes,
then
I'm with you.
the 66. Now, the easiest way for you to do that is then press equal or enter.
I get 16.2. I don't know.
Okay, yeah, wait, we're not
All
finished.
right. All right.
Okay, so we have 2 square root of 66. Okay, so I have 16.2480768,
Mhm.
right? Start 6.
Yes, yes. Mhm.
Okay, but we're not finished because if you notice, this still has something in the bottom. I pressed
Okay.
equal after I finished what was on top.
Mhm.
Then I press divide, just press divide button
Mm.
and put in 5 and press equal or enter or whatever.
Yes, I got it. Thanks. Yes, I got it.
So
Thanks.
do the top separately
Okay.
and then finish the bottom. I think that'll make it easier for you rather than
Yes.
trying to do it all in once.
Thanks.
Okay, as you notice, what Cheryl has been mentioning, you really have to get used to that calculator. Once you get used to it, you'll see why you want to use it. But you have to, it takes time and you just have to use it as much as you can. Okay, I want to do one more type of question and then I think we're going to go to review. Okay, so I just want to do one more question in trigonometry. So can I erase this now? Anybody still need this on the board? Okay. This is what I'm going to do. I'm going to do one more question, then I'm going to give you one similar to it. And then, as I said, we're going to go to review. So here's the type of question I want to ask you. Suppose I told you that the tangent of theta is given, it's 5/12. And I want you to find the secant of theta. this type of question where they don't give you a picture of the triangle and they don't give you the size of the triangle, but they give you one of the trigonometric values, and it could be any one of all of the 6, you should be able to draw a triangle and go on from there to figure out the way we did before. So since they didn't give me any triangle, I'm drawing the triangle. Once I'm drawing my triangle, I could put my theta any place I want. Obviously, it's not here because that's a right angle. I always like to put it at the bottom here. Now, what did they tell me about this? They told me that the tangent of theta is 5/12. And I know tangent is TOA, that the tangent then is the opposite over the adjacent. That's what TOA stands for. So that means in my triangle, I can pick the opposite side to be 5 and the adjacent leg to be 12. So let's see, here's my triangle with nothing on it. Well, I do know relative to this is my opposite side. This is the cross. This is my hypotenuse, because it's across from the right angle. And this is my adjacent side, because it's attached to the angle, okay? Now look at what I said. My opposite side, I'm going to pick to be 5. And my adjacent side, I'm going to pick to be 12. In other words, by telling you that the tangent is 5/12, I've really given you all the information about the triangle that we're going to be working with. I don't have to draw the triangle. I just have to tell you this. And it's giving you basically all the information on the triangle. So now let's go back. Now that we know what our triangle is going to look like, let's see what they asked me to find. They asked me to find the secant of theta. Now remember, secant is one of the secondary ones. And since secant starts with S, its partner starts with a C, which is cosine. So I'm going to first find the cosine of theta. And after I find the cosine of theta, I'm just going to flip it over, and that's going to be the secant of theta. So if you notice, we always sort of pick out the 3 primary ones. If they're asking us a question about the secondary ones, first go to the primary one and then just flip over the right one. As I said, in this case, it's going to be the cosine that we're going to be looking for. Now remember what cosine stands for. Cosine is adjacent over hypotenuse. Now what do we have so far in this triangle? We have the opposite. I don't even need it. We have the adjacent. We know that that's 12, but we don't have the hypotenuse. So again, how are we going to find the hypotenuse? We're going to use our Pythagorean theorem. Our a squared is 5 plus our b squared, 12 squared, is going to give me, remember this hypotenuse is always the c squared. Okay, 12 squared is 25. 5 squared is 25. 12 squared is 144. And when I add those together, 25 and 144 gives me 169. So c squared equals 169. So c is the square root of 169, which happens to be 13. 169 is a perfect square. If you're not sure if a number is a perfect square, just stick it into your calculator. Do the square root of 169. If it comes out to be a whole number, then it's a perfect square. If it doesn't, if it comes out to be a long decimal, then just leave it in radical form. So this side, the hypotenuse, turned out to be 13. So therefore, the cosine of theta is adjacent 12 over 13, which means that the secant of theta is 13 over 12. So as you notice, I always work with the primary ones, but if it's a question about one of the secondary ones, I then at the end go to the secondary one. Again, quite a bit of work for one problem, but that's all in that one, in those 3 rules up there. Those are the only rules that we're going to be using. Okay, I'd like to give you a question to try. Give you a couple minutes to copy what's over there. Okay, can I erase this now? Okay, I'm going to erase this now, and I'm going to give you a new problem. And while you're doing that problem, I'm going to take attendance. Suppose I tell you I have a triangle, an angle, and the cosine of that angle is 8 over 17. And I want you to find the sine of theta. So I'm giving you what the cosine of the angle is, and I'm asking you to find, well, let's do it a little more complicated. Let's make it a little harder, just to give us all the possibilities. I want you to find the cosecant of theta. Okay, see what you can do with that question while I take attendance. Okay, Azia, I know you're here.
Yes.
Good morning.
Good morning, Pussy.
Nashia Allen. Anna Belkis. Emma. Emma Benedict. Messiah.
I'm here.
Good morning.
Good morning.
Corey.
Here.
Good morning.
Morning.
April.
Good morning.
Good morning. Khadija.
Good morning here.
Oh, good morning. Umar.
Good morning.
Good morning. Yakima. Yakima Ellison. Cheryl, I know you're here. Stacia.
I'm here.
Yeah, I usually talk to you before this. Good to hear you. Denisha. Devana. Devana here?
Happy Friday, Professor. I'm here.
Oh, good. Natalie. Good morning, Natalie. I see. Erica, I know you're here because I spoke to you earlier.
Good morning, Professor.
Jonathan, I know you're here. Luke, I see you sent me a text. Layla. Layla here? Layla Naji? Ashley, I see you sent me a text. You're here. Kachira, I know you're here. Jennifer. Jennifer Ramirez?
I'm right here.
Okay, I usually talk to you before this.
I know, but I came on late today. I'm sorry.
Rachel Seeley. Rachel here? Okay. And Gloria. Okay, anybody want more time on this? Okay, so let's see what we can figure out. First of all, they didn't give me a picture of a triangle, but they did tell me what the cosine of theta is. So I'm drawing myself a triangle. And as I said, when they don't tell me where theta is, I usually like to put it at the bottom here. You don't have to, you could put it up here also. Remember that if I do it this way, then this is going to be my opposite side. This is going to be my hypotenuse. And this is going to be my adjacent. Now remember, if the theta is up here, then this becomes the opposite and this becomes the adjacent. But if you're setting it up this way, so your theta is over here, then this will be your opposite because it's opposite the angle. And this will be the adjacent because it's attached to the angle. Okay, they told me that the cosine of theta is 8/17. And we know that the cosine, so ka means it's adjacent over hypotenuse. There's my ka, AOCAH. So the adjacent side is going to be the 8 that I'm comparing this. And the hypotenuse is going to be the 17. So by telling me what the cosine of theta is, they gave me a right triangle, and they gave me two sides of the right triangle. Now let's go to what they asked me to find. They asked me to find cosecant theta. That's what we're looking for. Well, I know that the cosecant is the reciprocal of the sine. Remember, C goes with S. This starts with C. The one that starts with S is sine. And the sine of theta is so opposite over hypotenuse. And if I want the cosecant, all I have to do is figure out what the sine is and then flip it over, take its reciprocal. So let's see what I have. For my theta, I have a hypotenuse. The hypotenuse is 17. But I don't have what the opposite side is. I only have the adjacent. But that's where my Pythagorean theorem comes into play. A squared plus b squared, well, that's my 8 squared, equals c squared, 17 squared. It's over here, that's separate. So this becomes a squared plus 64 equals 17 squared. I think we had it before, I think it's 289. And I have to bring the 64 to the other side because the 17 was the c squared. So I get a squared equals, this is 225. A squared is 225, and if you do the square root of 225, you get that a is 15. So in this case, I figured out that the opposite side of the triangle has to be 15. So now, if I want to find the sine of theta, I can do it because I have opposite and hypotenuse. The sine of theta is 15 opposite over 17, the hypotenuse. So that means that my cosecant is just that thing flipped over, 17 over 50. Did anybody get that answer? Anybody able to get that? Oh, great.
Yeah.
Perfect.
I got the 15, but then I got stuck.
Okay, now do you see how to go further from that?
Yes.
You have to keep in mind, again, I always like to first find the primary one. I knew I had to find sine. Here I have, this is 15, and I knew this was 17. So that gave me the 15 over 17. And then I just flipped it over to get the cosecant.
Okay, then.
There's a lot of steps involved.
Yes.
What we needed to find the third side of the triangle. We had to make sure we put those 8 and the 17 in the right position. That's why, so I had to know what cosine was, adjacent and hypotenuse. So that would allow me to find the third side, the 15, which was the opposite side. And then once I had all three sides, I was able to do the cosecant. All right, I think we're good. And this is basically as much as you need to know on this chapter of trigonometry. Now, if you have the textbook, you will see this is not in the textbook. But I hope some of you took a look at the study guide that I sent you out. If you look on page 4, then you will see that there's a whole discussion. Remember, I gave you this study guide look for it on your information page in Blackboard. It's a review of all the topics that we did this term in Math 136 with examples. I also sent you an answer key to those examples. And as I do the review, I'm basically looking at this set of papers to see what I have to review. Okay, so now, unless there's any questions about this that anybody wants to ask me, what I want to do is spend the rest of the period doing a review of chapters 2, which is graphing of linear equations, and chapter 3, which is systems of equations. Let's go through the type of questions that you'll see on the final from those 2 chapters. Again, as I said, you'll find these sheets on in the Blackboard on the information section. And the information's the last item in the information section. I think it says review sheets for Math 136 is what I called it. Okay, so let's remember that one of the main things that we learned in chapter 2 was how do we write the equation of a line? For example, suppose I gave you this question. I'm just going to erase this because I don't want it to be. Suppose I asked you, I want you to find the equation of a line parallel to y equals negative 2x minus 1, passing through two, 4. So I have one line that they're giving me. I want to write the equation of a new line that's parallel to my original line, but that goes through a specific point 2, 4. See if you could write that equation. See if you remember how to do that. Okay, let's see if we can remember what we learned about writing equations of a line. If you recall, the standard equation of a line is y equals mx plus b. Whenever we want to write the equation of a line, there are two important facts that we're going to be looking at. One is the slope, and one is, which we call the m, and one is the y-intercept, which is the b. And I always try to work on figuring out the slope first. Now, in this case, the line that I gave you, the original line that I gave you had a slope of -2, because that's the number that's in front of the x. And since my new line is going to be parallel to that line, my slope here is also going to be -2. So my equation becomes y equals -2x plus b. The question is, what should the b be? What should the b? We know the m is going to be the same parallel lines have the same slope. So what should the b be? Well, the only other information they gave me is that the line is going through the point 2, 4, which means when I replace the x with 2 and the y with 4, this is going to be a true statement. So in place of y, I'm going to put 4, because that's the y value. In place of x, I'm going to put 2, because that's the x value. And see how this works out. So this is 4 equals -2 times 2, which is -4, plus b. I don't know what the b is. That's what I'm trying to figure out. But all I have to do is bring this 4 to the other side, which will give me that b equals 8. So my new equation is y equals -2x plus 8. Corey, you were right in terms of half the problem. Yes, it has the same slope, but what isn't the same is the y-intercept. In order for it to go through the point 2, 4, we need to replace the y with the 4 and the x with the 2 and see what that works out to be. And it worked out that the y-intercept for this line is not -1, which this one had, but plus 8. Is that clear? Yes, and Azia, you had that perfectly correct. But Corey, do you see why it's not the exact same thing? Yeah, okay, that's why we're doing this review. You remembered part and you didn't remember the other part. Well, let's do something that has to do now with perpendicular lines. Okay, let's try a different problem. I'm going to give you a couple minutes. Let's say I gave you this question. This actually is coming off that study guide that I looked at. Okay. We want a line that's going to be perpendicular to this line. 8x minus 9y equals 34. And that's going through the point, let's go through a different point. You know, 3 negative 1. I'm going to give you a few minutes to try that. Wait, let me change this. Let me make this 2 negative 1. Make it, it's a little bit easier with those numbers. Okay, let's work on this together now. They tell me they want a line that's perpendicular to the original line. And we recall that perpendicular means the slopes are not the same. The slopes are what we call opposite reciprocals. So what I want to first do is figure out what the slope of this line is. Now, unfortunately, the original line that they gave me, 8x minus 9y equals 34, is not in y equals mx plus b form. So the first thing I have to do is put this into the y equals mx plus b form, which means bring the 8x to the other side. So that'll give me negative 9y equals negative 8x plus 34. And then divide everything by negative 9. And what we really have to concentrate on is the coefficient of the x. The slope of my original line worked out to be negative 8 over negative 9, which we simplify to 8 over 9 because a negative over a negative is positive. And therefore, for my new line, here's my new line. What is my slope going to be on my new line? Anybody have any idea?
Negative 9 over 8.
Positive 9 over 8?
Negative.
Right. But when it's perpendicular, we have to take this number 8 over 9, flip it over so it becomes 9 over 8, and switch its sign. It's positive, the perpendicular line would have to be negative. So my new line would be y equals negative 9 over 8x plus b. My slope is negative 9 over 8. Now let me give you a little hint. When you're going to get this type of problem, it's going to be a multiple choice problem. Before you do any more work on this, because the next work is going to be a little bit of, it could involve fractions because I see fractions here. Look at your answers. Very often, the answers will be 4 different answers with 4 different slopes. If there's only one answer that has a slope negative 9 over 8, you can just pick that answer because that's the only possible right answer. Now, if it turns out that 2 answers, for example, have the same negative 9 over 8, you've got to then do more work. Again, if you don't have time to do more work, at least you've narrowed down the number of answers. So again, first work on figuring out what your slope of your line is going to be, and then checking your answers to see which of the answers have that slope. If only one has that slope, that's your answer. Don't do any more work. Just pick that answer. Okay, but I gave you this as an open-ended question. So I'm going to erase this part because we already used it. And I'm going to go on from here. How do I find the b when I know my slope is negative 9 over 8 and the point is 2, negative 1? So that means wherever I have a y, I'm going to put negative 1. And where I have the x, I'm going to put 2. So this will become negative 1 equals negative 9 over 8 times 2. Now, I'm going to put this 2 over 1 simply because I this part is a fraction, write the 2 as a fraction, 2 over 1 plus b. And I have to first multiply the negative 9 over 8 by the 2 over 1. Now, could you do this on your calculator? Yes, most of the calculators do fractions. But if you're not too sure about how to do it, let's do it without the calculator. Remember, when we're multiplying fractions, we multiply the tops together, so that becomes negative 18, and the bottoms together, and that becomes 8. And if possible, try and simplify. Negative 18 over 8 really reduces to negative 9 over 4. So in order to find b, I have to add 9 over 4 to both sides of this equation. Okay, so it turns out that I have to do negative 1 plus 9 over 4. Now, this is really negative 1 over 1. Let's make them both fractions. Again, you can use your calculator to do this, but if you have trouble or you don't remember how, just do it by hand. You have to find your common denominator, which is 4. So this becomes negative 4 over 4 plus 9 over 4, which equals 5 over 4. So your b turns out to be 5 over 4. And then you can write your equation this way: y equals negative 9 over 8x plus 5 over 4. Again, my feeling is that if they're difficult fractions, you're going to be able to pick the answer out by just looking at the choices. Any question about this? Remember, the other type of question they could ask is they could just give you 2 points and ask you to write the equation. Again, if you have 2 points, don't forget how to find the slope of the line. The equation for finding the slope of a line, if you have 2 points, here's the formula, is y2 minus y1 over x2 minus x1. So depending on the information they give you, if they tell you about parallel, you know it's going to have the same slope. If they tell you about perpendicular, it means you've got to take the original slope, flip it over, and change its sign.
Professor, how would we use this in our calculator though? Like, how would we do the fractions in the calculator?
Okay. Who's asking me this?
It's Jennifer.
Jennifer, okay. You and I have to have a separate extension on your calculator.
Okay.
You want to meet on Tuesday before class?
Okay, no problem. I will.
Okay, just email me, because I can give you general information about any calculator, but that's not going to help you with your calculator. I have to give you specific instructions on your calculator. And if you could take a picture of your calculator, or the front of your calculator beforehand, so then I'll know which one you do. I usually know how to, there are 3 or 4 different types that people use. Do you know which one yours is?
Is this Texas Instrument 3X?
3. 3x or 2x?
2S.
2x. Okay, that's a good calculator. Okay, I can help you with that. But we really have to do it one-on-one.
Okay. Okay.
But again, listen to me in terms of, I know the way they write these questions. And if there's going to be a lot of fraction work, I can't guarantee this 100%, but I can guarantee it 90%. If it's going to involve a lot of fraction work, you probably don't have to do all the extra work. If you just get the right slope, you'll probably be able to pick out the right answer. Okay, so again, if they give you that it's perpendicular, we flip it over. If they gave it 2 points and then you, to find the slope, you have to do the y2 minus y1 over the x2 minus x1. Again, all those equations and formulas are on that sheet that I gave you. Okay, so let's see what other kind of questions you could come across on so another thing is this use of, what if I gave you a question like this? It has to do with functional notation. Suppose I gave you that f of x is equal to negative absolute value of x plus 8. And I ask you, find f of negative 3. See if you could do that. Good, Jennifer. You want to tell us how you did this? Jennifer,
Yeah.
do you want to explain how you, I see you got the right answer, so I want to see how you did it.
I put the -3 in a parentheses plus 8.
Okay, so this becomes negative
3.
absolute value negative 3 plus 8. When it says find f of negative 3, it means take the x and replace it by negative 3. Okay, so how much is the absolute value of negative 3?
-3.
Well, we have it, then what about this negative on the outside? Remember, the absolute value of a number, those two straight lines mean absolute value, and that means that you're, if I want
Positive.
the value of any number, I always drop its sign. The absolute value of negative 3 is 3. But now there's a negative in front of it. So this is negative 3 plus 8. And that's right. You're completely right that that is equal to 5. But this is what we call functional notation, where you replace the x by whatever number you're given. Don't forget, when you're doing absolute values, the absolute value of a number is the positive value of the number, where you drop the sign. So this alone is 3, because we're dropping the sign. And because there was a negative in front of this, that made it negative 3. So it was negative 3 plus 8, which is 5. Okay. So let's do just one other question and then I'm going to let you go. And that has to do with a question about writing a system of equations and solving the system of equations. What if I told you that 400 tickets were sold to a concert? So a total of 400 tickets were sold. And there were two types of tickets. There were adult tickets that cost $4 each. And there were children's tickets that cost $3 each. And the total amount of money they made on this concert is $500. Tell me how many adult tickets were sold and how many children tickets were sold. So we know how much each of the types of tickets cost. We want to know how many, if we got $1,500 altogether for these 400 tickets, I want you to write a system of equations and solve it to find out how many adult tickets and how many children's tickets were sold.
Children, is it $3?
What?
$3 for the children tickets?
Three, yes. $3. This is 4. And this is 3. Is that better? And this is 400 tickets and $1,500. Okay, let's see if we can write the equation, the system of equations, and solve the system of equations. Okay, So we have two types of tickets. Let's call the number of adult tickets, let's call that X. And let's call the number of children's tickets Y. Remember, when I write this down, this is what's called creating a legend. It's reminding me what I'm using for the X and what I'm using for the Y. So I have two variables. One stands as X, that means how many adult tickets were sold, and one is Y, because that's what I was asked to find. How many adult tickets and how many children's tickets? In other words, I know what to make my variables based on what I'm looking for. Now, the first fact that we know is that the total number of tickets, that's both the adult and the children's tickets together, was 400. So that must mean that the X plus the Y is 400, because the X and the Y stand for how many tickets were sold. It has nothing to do with how much each ticket costs. It's just how many were sold. The next bit of information has to do with money. We know that $1,500 was spent, was collected. So the amount of money they made from the adult tickets was 4X. Because if X adult tickets were sold and each of them was $4, they made 4X. In other words, if there were 100 adult tickets sold, then 4 times 100 or $400 would be made from the adult tickets. From the children's tickets, they got 3Y. Y is how many tickets were sold times 3, the price of each ticket. And together, the 4X and the 3Y is equal to 1,500. All right, now we want to solve the system of equations. And we want to either get rid of the X or the Y. What should I get rid of, the X or the Y? Any suggestion?
You get rid of the X.
Okay, if we want to get rid of the X, then since this is 4X, I'm going to have to multiply this one by 4 and this equation by 1. And I have to think, do I need a negative or not? Can I just use positive numbers, or do I have to put a negative?
Negative.
I have to put a negative because, it doesn't matter which one I make negative. I don't make both of them negative because I want them to end up being the same number, but one being positive and one being negative. So if I multiply my top equation by 4, I get 4X plus 4Y equals 1,600. And the bottom equation I'm multiplying by -1, so that becomes -4X minus 3Y equals -1,500, because I'm multiplying everything by -1. And when I add these two equations together, the X's cancel out. That's what we said we wanted to do. The 4Y and the -3Y gives me just plain Y. And the 1,600 minus the 1,500 gives me 100. In other words, my Y, the number of children's tickets sold, is 100. Now, if the number of children's tickets is 100, how many are adult tickets? Now, you have to be very careful because sometimes they ask you to find both. Sometimes they ask you to find just the adults. Sometimes they ask you just to find the children. But be careful you match them up properly. That's why I wrote down that the Y were the children's tickets and the X's were the adult tickets. My original equation said X plus Y equals 400. So now over here, I can do X plus, well, I know the Y now is 100 equals 400. So if I subtract 100 from both sides, I get that my X equals 300. You might have just thought it out in your own. If 400 tickets were sold and 100 of them were adult tickets, of course, the number of adult, if 100 were children's tickets, then the adult tickets, there were 300. Okay, So that basically takes care of chapters 1, 2, and 3. That doesn't mean you can't ask me questions about chapters 1, 2, and 3. When you're doing your review, you can ask me as well. Does anybody have any questions? Don't forget, if you haven't done the Delta Math Quiz 4 yet, you can do it for late credit. You can do it until May. But if you want to get full credit, then you have to do it by tonight. Also, make sure you're keeping track of the homework. I will be putting some homework on trigonometry on the Delta Math. Okay, anybody have any questions they want to ask me? Okay, if not, have a nice weekend. I'm
Have a
gonna,
good weekend. Stay safe.
okay, you too.
Thank you, Professor.
Leave Melissa in charge. Have a great weekend, everybody. I hope it's supposed to be nice weather. Today is.
You too.
Bye.
Bye-bye.
Hey guys, I can't do class today, but as I said, I have class tomorrow. So if you guys want to come to the learning center, you guys can definitely do that.
I have plans for tomorrow already.
What time do you have class?
Pardon me?
What time you normally have class?
No, I said I have plans for tomorrow.
Oh, okay.
Yes.
Yeah, I can't stay today.
All right, thanks.
But you already know. You guys can always.
Yes, I know. Yes. Thanks for that.
All right.
Yeah, bye. Have a blessed weekend.
Same to you guys.
Thanks. Hello? Anybody? Uma, Ashley, did they leave?